Okay, maybe you're not convinced that you're looking at a real ghost in this image, but what are you looking at? Let's find out the trick behind this illusion and a whole lot more in this segment of Physics in Motion on reflection. Reflection is when a wave bounces off of a surface when it interacts with a material. Both light and sound waves reflect, but in this segment, we're going to focus on light. We know this behavior intuitively. When light hits something, it bounces off. When light rays hit an object, they obey what we call the law of reflection. The law states that the angle of the reflected ray equals the angle of the source ray when bounced off of a surface. We call the light rays coming from the source, say a laser pointer, the incident rays. At the point where an incident ray strikes the surface of an object, we can draw a line perpendicular to the surface of the object. This line is known as a normal line, the one labeled N. We measure the angle of incidence between the incident light ray and the normal line, and the angle of reflection between the reflected light ray and the normal line. Remember that according to the law of reflection, the angle of incidence equals the angle of reflection. Because of this, the normal line divides the angle between the incident ray and the reflected ray into two equal angles. If I shine this laser pointer at an angle of 45 degrees from the normal line, the reflected ray will also be 45 degrees from the normal line. Makes sense, right? Now there are two kinds of reflected light. The first is called specular reflection, which is when light is reflected off of a shiny or glossy surface. It can be a lake or a metal pan or a mirror. Light is coming from a single source and reflected in a single direction. If the shiny surface is smooth, you'll get a pretty good approximation of the object that the light is bouncing off of in the reflected image, like this plane mirror. A plane mirror is your basic flat mirror, like the one you have in your bathroom. But what do you notice about the reflection? The letters are reversed. Or are they? What we call the left-right reversal of an image is simply a frame of reference phenomenon. But what if your shiny surface that the light rays hit is curved? Your side mirror in your car is made this way, curved into a convex shape so that it reflects more in a smaller space. The image form shows a larger space in a smaller reflection. If the curve is inward into a concave shape, you get lots of interesting effects, including magnifying the object. So that's specular reflection. The other kind of reflection is called diffuse reflection, which happens when light rays hit a rough surface. That could be wood, cloth, or the leaves of a plant. The roughness of the material means that each individual ray hits a surface that has a different orientation. The normal line at the point of incidence is different for different rays because of the irregularities in the surface. That's why the light rays are reflected in many different directions, but these rays still obey the law of reflection. When you have a specular reflection in a mirror, the shiny kind, you see an image of the object, but it can be one of two different types. One is a real image, which is when the light rays converge on a surface. The real image doesn't mean you can touch it, but it can be projected. The second kind of image is called a virtual image. A virtual image forms in locations where light converges in the virtual world behind the mirror, so to speak, and the image cannot be projected onto a screen. For instance, my face in the mirror is actually a virtual image. It may look like the light is originating from the mirror, but it isn't. It's coming from in front of the mirror, from the bulb. Remember our ghost? How do you think we created it? And what kind of image do you think it is? Let's reveal the mystery. The image is called a Pepper's ghost, after the guy who first projected one successfully back in 1861. It's been used in amusement parks and magic shows ever since. It may look like a hologram, but it's completely different. It works like this. You need two rooms, one to be the stage that the viewer sees, and the other out of sight. A pane of glass angled between the viewer and both rooms. The audience can see the stage, but not the glass. When the lights in the side room are turned on, light travels from the ghost to the glass. Some of the light is reflected by the glass and reaches the viewer. The viewer sees rays of light from both the stage and the hidden room, projecting the hidden image. It's an optical illusion, in other words. What kind of image do you think it is? Virtual or real? If you thought virtual, you were right. The light is converging beyond the mirrored surface. Over the next few days, look around you and see if you can figure out what's specular and what's diffuse, what's real and what's virtual. It'll all become crystal clear. That's it for this segment of Physics in Motion. We'll see you next time.
For more practice problems, lab activities, and note-taking guides, check out the Physics in Motion Toolkit.